Howdy, howdy, howdy. Here is the instruction video for lesson 3 and for lesson 4. So we're jam-packing two of them together. Why? Well, because the strategies we're going to learn in lesson 3 and lesson 4 are pretty darn similar. And the main thing they have in similar, just like all the other strategies we're learning, is that they make multiplication quicker. They make it easier. That's the whole point of this strategy. It's not to make more work. It's not to be a pain in your butt. It's to make things easier and quicker. Because when you guys are out and about, maybe you're at the store or the grocery store or whatever, you have to do math all the time. And you want it to be quick. You want it to be quick. You don't want to be in the line at the store taking 2 minutes to figure out what 5 times 9 is or whatever. So again, that's why we're learning these strategies, to make your calculations faster. Or as you kids might say it, do some quick maths. Anyway, I'm probably dating myself. Anyhow, let's move on. So lesson 3, what it's talking about is using other math facts to help you with a calculation. So one thing that I just want to highlight to you, if you haven't been doing this already, these workbook pages, some of them are really good, some of them aren't great, but they all have these at-home helps on the side, and they are fantastic. They're usually really good, really to the point, and they're going to be helpful to help you learn these. So while you're studying, I encourage you to read these. And we're actually going to go through this right this second. So it says you can use one multiplication fact to help you calculate another fact. So for example, let's just say I said, hey, 5 times 6. I know that 5 times 6 is 30. And the reason I know that is because I'm pretty good at my 5 facts. I can times by 5 pretty well. And that's true for most people. Most people really prefer their 5 facts. They can figure out a times by 5 pretty darn quickly, okay? So if I know that 5 times 6 is 30, I can use this to help me figure out the product of other multiplication sentences. So let's say I had 6 times 6. All right. Well, I know what 6 times 5 is. 6 times 5 is 30. And I know that that just means 6 times 6 is just really one more group of 6. Over here, I only had 5 groups of 6. But they want one more group. So 6 times 6 is really equal to 30 plus one more 6. And if you're thinking, Lewis, this looks really familiar, it should. This is the count up or the count down strategy that we learned back in lesson 1 and lesson 2. Okay? So yeah, this isn't really anything new. We're using multiplication sentences that we're strong with to help us with ones that we're not. And then of course, 30 plus 6 is 36. Absolutely. Okay. Other examples, well, let's take a look here. Let's say I had 21 times, say, I don't know, 11. That's a tough one, right? I might need to rewrite this as a standard algorithm. So 21 times 11, right? And this is fine, but again, when you're in the store, you're not going to have a notebook, you're not going to have a pencil, you're not going to have time to sit down and do standard algorithm. We got to do this mentally, really quick, okay? So what I can do is I can pretend that 10, or rather that 11 is 10, and I'll just go 21 times 10. 21 times 10, well, I know anything timesing by 10 is just 21 with the 0 on the end. Awesome. But again, that's not the whole product, right? I needed 11 groups of 21. I only got 10 groups of 21. I need one more group. So I'll add that last group of 21. Yeah. That means I've got 1 1, 3 10s, and 2 hundreds. Cool. So I'm using multiplication facts that I'm strong in to help me with multiplication facts I'm not. And that's what you're going to be doing on this page here. The example it gives us is 4 times 3. Okay, so it says I know that 4 times 9. 4 times 9 is 36. And then it says I can use this fact to calculate 5 times 9. If 4 times 9 is 36, and 5 times 9, that just means you have one more group of 9, which means you've got 36 plus that last group of 9, so plus 9. And you betcha, that's 45. So really nothing super new with lesson 3. They were just specifically saying, hey, use multiplication facts that you're comfortable with and then add on top of those. For example, here's another one. Let's say I've got something ridiculous. Let's go 22 times 33. Woof. Okay, yikes. 22 times 33. Well, you know what? I'm going to go 22 times 30. Oops. 22 times 30. Actually, I'll go ahead and go up by 3. Let's go up 22 times 3. Well, I know 3 times 2 would be 6, and 3 times the other one would be 6, so that's 66. Awesome. Okay, so that's the ones. I multiplied 22 by the ones. And I'll do it by the tens. How many tens do I have? I've got 30 of them. Cool. And that's going to be the exact same answer, but with a 0 on the end. Awesome. Oops. 0. Add them all up. 6 plus 0 is 6. 6 plus 6 is 12. Carry the 1. 1 plus 6 is 7. I didn't do a very good job of aligning my place values there. Cool. So tougher one. Absolutely. That's going to take a lot of mental arithmetic to do that one. That's a tough one. I'll admit that. Let's do one last one. Let's say they gave us 7. Sorry, I'll use a better font. 7 times 13. I'm a math teacher, and I don't know what that is off the top of my head. I'd have to sit down and think about it. Well, you know what? I do know what 7 times 10 is, because I'm pretty good at my 10 facts, and most people are too. 7 times 10 is 70, absolutely. All right. Well, then on top of that, I know I need 3 more groups of 7. So I could go plus 7, plus 7, plus 7, and go 70, 77, 84, 91. That works. Or I could do something different. I could recognize that 3 sevens is actually 21 and just go plus 21. 70 plus 21 is 91. Okay, that also works. Or heck, if I really want to be careful, I see that I've got, hey, 7 times 10. Okay, so that's 10 of my 13 groups. Now I just got to do the last 3 groups. 7 times 3 is 21. Cool. So I've got 10 of the 13 multiplied. And then I've got the last 3 of the 13 multiplied. Add all the parts up. 1, 9, 91. Okay, so there's lots of different ways we can wrestle with this. And you just need to practice these. Sorry, the phone's going off. Practice these. Find out what your preference is and then dig into that. Use it and get good at it. You need practice and you need experience if we're going to get good at this. Cool. Let's slide down to lesson 4. And this strategy, we were actually using it a little bit earlier. And you may have noticed I was multiplying tens pretty easily. And the trick I was using, you might already know it, that's okay if you do, is if I'm ever timesing by 10, well, first I'm just going to multiply one of my factors, the factor that isn't 10, that factor by 1. And everything times 1 is just itself. We knew that. But I'm not timesing by 1. I'm timesing by 10. So I add that 0 on the end. Okay. Now, if you're wondering, why can that trick work? Like, why can I just do that and be confident that I know I'm right? Well, if we set up the standard algorithm, first I multiply by the 1s. So 0 times 1 is 0. 0 times the 2 is 0. Awesome. And before I start multiplying by this 1, I need to put a placeholder down here because I'm not multiplying by 1. I'm actually multiplying by 10. This is the 10's place value. 1 times 1 is 1. 1 times 2 is 2. Add them up. You betcha my answer is 210. So there, I've got more proof that this strategy does work. Okay. Now, what if, sorry, this phone's going crazy. What if I wasn't timesing by 10? What if, say, I was multiplying by, say, 20? Does that strategy still work? Absolutely it does. I'm not going to treat this like 20. I'm going to treat it like it's 2. Okay, so 21 times 2, well, I'm just doubling 21. So yeah, that's 42. But think about that. 21 20 times, is that only going to be 42? No, that's just 21 times 2. So I have to add that 0 on the end. My answer is going to be 420. And again, if you don't believe me, let's double check. We'll use standard algorithm to double check. 0 times 0, 0 times 1 is 0, 0 times 2 is 0. Multiplying with the 20, so I need a placeholder. 2 times 1 is 2. 2 times 2 is 4. And you can see adding nothing to that would give me 420 still. Cool. So it absolutely works. Now you might be wondering, though, what about hundreds or thousands or 10,000s? Good news, this strategy still works. There's only one more wrinkle. And that wrinkle is this. Let's say I was saying 14 times 100. Well, firstly, I'm going to treat 100 like it's just 1. And 1 times anything is just that same thing over, right? 14 times 1 is 14. And then however many zeros you have, you slap them on the end. Just like that. 14 times 100 is 1,400. We could also read this as 1,400, which makes a lot of sense when we're multiplying, right? 14 times 100, you have 1,400. Or if we're thinking dollar bills, this is a $100 bill, you've got 14 of them. How many do you have? $1,400 bills. There you go. You could do the same thing with as big a number as you want. Like, say, I don't know, $1 million. You've got 14 briefcases with $1 million in each briefcase. How much money are you going to have? You're going to have $14 million. 1 times 14 is 14. And then I look at all the zeros. I see 3 zeros. I see 6 zeros. So I'm slapping on 6 zeros. Notice I'm still using commas for every 3 place values to split up my periods so that I can read the number easy. Okay, but there's the strategy right there. Easy peasy. Just because it's a big number doesn't mean it has to be a big pain when you're multiplying it. And again, it doesn't always have to be like 1, 10, 100. It can be 200. It can be 700. It can be 9,000. Proof, check it out. 3 times 90,000. What's 3 times 9? That's 27. Count the zeros. 1, 2, 3, 4. 1, 2, 3, 4. And that would be 1, 2, 3. 270,000. Just like that. Okay? So that is largely what you're going to be using on this workbook page, and more importantly, for the rest of like your life, using multiplication. Okay, you got zeros on the end, pretend they aren't there, multiply just by the number in front of it, and then re-add the zeros on after. Now, if you're a math teacher watching this, I hope I'm not screwing this up too bad, and hope you're not critiquing me too hard, but you might be screaming at your TV or your smartphone or whatever, saying it's not just adding zeros, it's actually moving the decimal point, which is true. But when we get into older grades, we'll learn more about what that actually means, moving the decimal. For now, worry about the zeros. All right. Okay, guys, have fun working on this. Good luck.